Howdy, everybody. Hope you're having an amazing day. We're in December, at least I am, and we're back for Advent of Code 2024. I'm really excited. I actually haven't done puzzles in a little while. I tried to do a couple, and I still want to finish some of the puzzles we've been working on, but just life and stuff has gotten really busy. So I'm excited though. Advent of Code is a good way for me to tell everyone, hey, I'm really excited about this, and they kind of let me do my thing. So here we are, Advent of Code. You'll see things are a little bit different. I'm here on Windows. Um, that's just because of a couple. I had a couple comments from people, coworkers, and stuff that just like, oh, it can be really hard to work on Linux and stuff like that. So I thought I'd give it a try on Windows. Like I think maybe the point that I try to illustrate to everyone is just get started. Whatever you have, even if it's just Notepad and a terminal or, VS Code or an online editor. Maybe a couple of these days I should try and use an online editor. They're great ways to like just get started, and that's what you do. It's fun to tinker and to work with your editor. That's part of being a programmer is working with your tools and figuring things out how you like it and setting it up properly. And I've done that in the Linux ecosystem, but I think you could be probably just about as happy anywhere you go. Just because these days you can really, change them to how you like. Right? If you really like Windows key bindings, you can do that just about anywhere. Vim key bindings can be done just about anywhere. Emacs, the same thing. So anyway, that's why you'll see me in VS Code today. If you see me fumbling it around, it's because I'm still a little new to VS Code uh, and all that stuff. So um, here we go. Let's start with day one. We're going to do a live solve today. We'll keep doing live solves until they get hard enough that it takes me a couple hours to figure it out, or I have to do it over several sessions while I'm doing things like chores and things like that. So here we go. Day one. Historian hysteria. The chief historian is always present for the big Christmas sleigh launch, but nobody has seen him in months. Last anyone heard, he was visiting locations that are historically significant to the North Pole. A group of senior historians has asked him to accompany them to as they check the places they think he will most likely visit. Oh, so is this like some kind of time machine type thing? At each as each location is checked, they will mark it on their list with a star. They figure the chief historian must be in one of the first 50 places they'll look. So in order to save Christmas, you need to help them get 50 stars on their list before Santa takes off on December 25th. Collect stars by solving puzzles. Two puzzles will be made available on you each day of the advent calendar. The second star is unlocked when you complete the first. Each puzzle grants one star. Good luck. Okay, so that's a pretty typical intro. They kind of give you an idea of what you're going to be doing over the next 25 days, right? You haven't even left yet, and a group of elvish senior historians has already hit a problem. Should I zoom this in a little bit? Uh, uh, uh. Their list of locations to check is currently empty. Eventually, someone decides that the best place to check first would be the chief historian's office. Upon pouring into the office, everyone confirms that the chief historian is indeed nowhere to be found. Instead, the elves discover an assortment of notes and lists of historically significant locations. This seems to be the chief historian was doing before he left. Perhaps these notes can be used to determine which locations to search. Throughout the chief's office, the historically significant locations are listed not by name, but a unique number called a location ID. To make sure they don't miss anything, the historians split into two groups, each searching the office and trying to create their own complete list of location IDs. Okay, so it feels like maybe some kind of sorting problem or something. We'll find out. There's just one problem. By holding the two lists up side by side, it quickly becomes clear that the lists aren't very similar. Maybe you can help the historians reconcile their lists. Okay, so it is some kind of sorting reconciliation. So here's the two examples on the left-hand side. You can see where there's clearly not a 1 over here or a 2. There's not a 5 or a 9 on the other side. Maybe the lists are only off by a small amount. To find out, pair up the numbers and measure how far apart they are. Oh, we aren't even going there. We're just doing a diff between these two numbers. Pair up the smallest number in the left list with the smallest number in the right. Oh, okay, so we are going to do a sort. And then the second smallest. With each pair, figure out how far apart the two numbers are. You'll need to add up all of those distances. For example, if you pair up a 3 from the left with a 7, the distance is 4. A 9 with a 3 is a 6. Okay, so yeah, this is just a fairly simple, we're going to sort both sides, and we are going to then do a diff as we go down the list. Presumably, like this puzzle input is the same size. I presume the other puzzle input will be the same size too. Okay, so the numbers are much larger. Well, relatively larger, right? These are still relatively small. Okay, my first task is, do I know how to new file input? I did install Vim bindings here, so okay, there are about 1,000. Okay, so this is one thing that I always like to think about when I'm doing sorting is how big is it? And you know, you might say to yourself, well, why do you even care? And that's probably true for most days. Like an average programmer will just use, like I'm going to be using Rust, so you could just use Rust's sort method, right? And then you're done. You don't have a problem with it. And that's probably okay. Maybe we want to implement our own. We'll see how much time I have or what we want to do. And that might be fun to do, to re-implement like a very simple sort, like a selection sort or a bubble sort, something like that. And the reason why that's probably okay, we'll look at day 2 and see how hard it gets, is because this is really small, right? It's one thing to say, oh, I need to sort 1,000 records. It's another thing to say, oh, I need to sort a billion records, right? Then you get into the area of like where your sort algorithm may be important. But for now, I think we can just, use what we got here. I probably want to pull this out. Actually, no, maybe I'll leave it in here. So we'll just start with, make sure I'm in the right place, and we will let input equal input string. Is that not it? Sorry, you can see I'm already flailing a little bit. Oh, it's not input, it's include, right? There we go. Okay, so now we have our input, and it came in. Ooh, should we just do the test one, just to show what it looks like? So we'll just start with the test one. Let's make a new file. Call it test. Am I in Windows? Should I be calling these like test.txt and input.txt? Rename input.txt. What is the rename? F2? Okay. Test.txt. Okay, we'll put our sample in there. Let's keep this one. Okay, so now we have our test data. Maybe I'll even slide it over here to this side. We probably don't need that much space. And so we've got 2 lists of files. That's probably something to think about. And they're together on the same page or on the same line. They have 3 spaces between them. Is that the same with these? 1, 2, 3. It's not even a tab. There's literally spaces. So it might be something where we can just split by 3 spaces and then collect two sets of lists. So how would that look? We'd say like let left right equal input dot split, or let's do lines dot we can fix this up in a minute. So let's do the lines dot collect lines dot split space split lines dot split by, this thing really isn't helping me. Let me go look at the split string. I will learn how to, I mean, it is just split and collect. Okay. So lines, oh, maybe it's because it doesn't know that this is a vector. So then we do lines dot split 1, 2, 3. So we're gonna split it by 3 lines. Dot. We kind of want to change this, right? So we now have our split set, and we want to like collect them separately. This might be easier in maybe to start with a for loop, and then we can go into like the functional style things, because it would be like a split and then a what am I trying to think about? Like when I split, I now have like a oh, I know what I'm doing. Lines dot hitter dot split. I'm kind of, it's been so long since I've done this stuff. I want to, it's the equivalent of a for each map. It's coming to me. Map. Okay, it's helping me a little bit here. Let's do so we get the string in, we split it by 3 spaces, and then we're going to this is why it's gonna, let's see, let's try and format this a little bit so it makes more sense. I probably don't want to unzip, but let's see. We'll go like let pairs equals split collect vex string. We'll want to put this in braces because we're not quite done yet. And then we'll return pair 0, 1, something like that. And then this is, we're going to we now have 2 of them, so we're going to collect like that. Oh, Getting closer? Okay. So, I mean, that looks okay. We could actually do this then in, we could say like input dot lines. We could do it in one line like that. Oh, it's not. It's going to be something like that, right? It was dereferencing it because I was using a vector of lines, but now I'm doing it in line here. Okay, so this is fairly functional, right? Right now we're just saying, I apologize if I've been fumbling. I haven't done this quite a bit. But we're basically just saying read in the string, iterate over the lines, and for each of them, we're going to do a mapping. We're going to split them and then take each of the two parts and return those as a string. Oh, we want them as an integer though. So will into work in here? If I do this and then I do them as a int 64. I mean, I don't know if that's going to work, but let's just yeah. Oh. It's I64, right? It's been a little while since I've done this in Rust. So we're going to recap all of it together. What does it think? Type annotations can into for string. I may just have to do the parse one, right? Or Rust string to int. Yeah, just do the parse unwrap. Okay. Do I know the... Oh, that did work. Okay, that looks like it got us our numbers, right? So we now have the two sides, and presumably we just sort and diff. Okay, so these will have to be mutable. And then we'll say left dot sort, right dot sort, and then we'll do left dot zip right LR. What is the absolute value one? Oh, I bet it's dot ABS. So if we just do L minus R dot AB sum like that. So, and then we'll do probably have to iter these. Is that what it's mad about? 11. Was that the answer for the test sample? Yep. Okay, so what is all this doing? Again, this is just functional stuff. It's slowly coming back to me. But the idea with a lot of this is it's really easy to iterate over arrays and do things with them. I could probably improve this even more, so we'll go back and look at it. But the idea is we read in our stuff and we parse it into integers. Then we do a sort. And then we basically iterate over both of them, zipping them together after they've been sorted, right? The reason why we have to sort first and then we can kind of zip them back together is because they are, we want them sorted first, right? But then we just subtract the two of them. We can take the absolute value and then add up their differences, right? Yeah, that'll always work, right? Whichever sides, it doesn't really matter which side is bigger because we just take the absolute value. It's really just the difference of the two. And presumably an int64 is big enough for now. Okay, so let's try it with the input code. My key bindings kind of work in VS Code. I installed like a Vim plugin for it. Okay, but let's run it with the input. Oh, apparently that does not work. So here's day one, part one. Who did that? What is copy here? Control-Shift-C. Let's try and submit it. Got it. Okay, part two. Your analysis only confirmed what everyone feared. The two lists of location IDs are indeed very different. They are very different. That's for 1,000 numbers. It's like 4 orders of magnitude different. Can't agree on which group made the mistake or how to read most of the chief's handwriting, but in the commotion you notice an interesting detail. A lot of location IDs appear in both lists. Maybe the other numbers aren't location IDs at all, but rather misinterpreted handwriting. This time you'll need to figure out exactly how often each number from the left list appears in the right list. Okay, so there's a question of uniqueness then. There's like on the left side, how many ones are there? And then on the right side, how many ones are there as well? Calculate the total similarity score by adding up each number in the left list and multiplying it by the number of times that number appears in the right list. I'm going to have to read that. Well, let's go through the example. Maybe it'll start to make more sense. I'll just read it one more time. Calculate a total similarity score by adding up each number in the left list after multiplying it by the number of times that number appears in the right list. Okay, so we're going to take the 3. We're going to look for all the 3s. So there's 3 3s. 3 times 3 is 9. Is that right? Yeah, the first number on the left is 3. It appears in the right 3 times. Second number is a 4. It only appears once. 2 doesn't appear at all, so it's 0. Okay, so we're going to take all these multiples and add them up. So this is a lookup list style thing. Excuse me. This is kind of a lookup list style thing. So I presume Rust has a find command, but my thinking is like now that we have both sides sorted, we can take this one, see how many times it's in there, and you can see, notice it each time there's a 3, it does it again, right? And so we really just need to know how many are in each of these. Oh, we could actually do, should we turn the right side into a hash map where the value, where the key is the number and the value is the number of time it's been seen? Then you can do a simple O1 lookup and say Oh, 3 is in there 3 times, so we multiply by 3. That's probably the right way to do it. So, okay, let's go back to the test data, and we'll try and do that. Yeah. So this is for part 1. We still can keep the left and right sorted, but let's do like let map equal. There's a way to do this. Should I just look it up? Rust list to hash map count. No. Maybe it is the fold. It's this that I was looking at. Let's try it that way. I swear there's an easier way to do it, but it's not a bool though. So entry like that. Key is X. Oh, I need a dereference. Yeah. Okay. Can I fix this? What is the VS code for refactor replace qualified? Yeah, there you go. Replace with use. Okay, I wonder if there's. Okay, I don't have that one set up. My in VS or in like NeoVim or whatever, it's space LR for me for like language refactor. Okay, so but here's essentially what we're doing is we're going to take the right hand side and we're going to use this fold operation, which says, hey, given this object or given this data structure, call this function that includes this as well as the new value and run it on it. And so essentially what you can do is you're folding in all of the values into this hash map. And I swear there's an easier way to do this. So let me think about it a little bit more. I don't see anything. I mean, they are still using. A lot of this is talking about the efficiency of it. And like, so in our case, we're using integers, easy enough just to copy them or whatever. But like, if you were using a string, using pointers would probably be faster. I think that's what that was talking about. Rust equivalent of Python. What is it called? A counter in Python? Okay, I mean, there is a package with a counter. I don't know that I want to use a whole new one. Okay, we'll just stick with what I got. It is a little weird looking, but we'll stick with it. Okay, so now we have a map of the right hand side, so it's really easy for us then to just say like let p2 equal left dot iter dot map x, and x will be x times map dot get x dot unwrap or 0 dot sum again, and we'll print p2. Okay, how much of that did I get wrong? What does get return? Yeah, an option, and I want to unwrap or 0. Oh. Okay, we just have to help the compiler out a little bit and let it know what type it is. So what are we doing again? A lot of this is why these are pointers, is just because we're iterating over it, over the list, and so it's going to give us a pointer to the item in the list. So if we don't find one in the map, did I say list? I mean map. If we don't find one in the map, we want to return the default, and then we just, which is 0, and so we'll iterate over all of the numbers on the left-hand side, multiply it by the number of times we found it on the right-hand side, sum that up, and that should be P2. Okay, it was that. So 31, that's what we got here. Okay, so let's do it with the actual data. OVGC, VGC. Oh, if I just, I can just shift V there. Okay. We'll do it with the actual input. Like that. Submit. There we go. Day 1. Okay, day 1 is done. So this one, probably like most of them, fairly easy for the day 1, right? Is like, I think most day 1s are just like simple algorithms. Like if you've taken an early computer science class, or, I mean, I don't even think, you could probably have just solved this by saying like, oh, I just need to sort the two numbers and then I can solve it. And that would have probably worked. So here's day 1. I will post these and put a link to them in the description. But I don't know. Let's look over it for a minute, just see if there's anything we could do to improve the code. It definitely looks different in VS Code. Like by default, it's adding the types. I don't know. Maybe that's good or bad. I don't know. It looks different, and so I'm okay. I'll just have to get used to that, or maybe there's some way to disable it, and I just haven't paid attention. I mean, this is like ticky tacky. I probably don't have to collect here. I can just do a next unwrap. So I could potentially do that. How would that look? If I just do a split right here. What's going on? So we do that. And then we do a oh, I do need to unwrap here too. Oh, it needs to be mute because now I'm not collecting on it. Like, does that look better? I'm always, I mean, we are just doing puzzles. So these unwraps don't have a lot of meaning. But like in real production code, like how often do you want to have an unwrap? Like my guess is almost never. Um, Obviously they're like the only way you'd want to unwrap is if you were like 100% sure that, and it would literally have to be 100% because in the other case you'd probably just want to return an error, right? Assume you're in some function and you say, oh, this function is going to, yeah, parse an integer at some point. If that parse doesn't work, you want to return an error, right? That you can like bubble up. Um, so I usually wouldn't normally do these unwraps. I mean, in this case, it's probably okay, but does this look better than what we had before? No, I don't know that it does. It's potentially more efficient because I haven't had to collect it. And so you're like one data structure smaller. Anyway, I'd be interested to see what you all think about that. How do you feel about this version versus collecting and then using the two values? Like the other part is using the two values isn't always safe either, right? Again, we know our data input is safe, so maybe that's okay. But I just literally indexed the two values, and maybe that wasn't okay either. Um, you'd probably want to do a check here if you were really doing secure style coding, which is really a big thing these days, right? You'd probably want to check to make sure there's two values so you don't blow up your system or blow up the program. Anyway, yeah, I mean, I think the functional programming can make it look a little confusing if you're not used to it, but it feels pretty clean to me. This zip is used all over the place. Like the reason I was better with the zip in the maps is because just familiarity with other things. But it has been a long time since I've done this stuff, so we'll have to get back into it. You just have to. These are great functions to remember when you're doing these things, especially if you're doing in Rust. Zip, map, fold, sum. Those things get used a lot, right? So the idea is you're iterating over a list of some kind. You want to do something with that list. These are tools that you use all the time. If you have a better way of doing this counter, I would love to see that. Show me your code. Let me know how you do it differently. Again, I'll post a link so you're welcome to like fork it and show me yours or stuff like that. So I'd love to see what you did to it. But again, just to recap, pretty easy day. Most of my struggles were just getting back into Rust. You know, most of my daily programming is in Go, C, Python, bunch of CI/CD languages, right? Things like that. So JavaScript, things like that. But I try and do Rust as I have free time. So I'll keep doing it for this. Hopefully, it goes well. So I think those are my biggest struggles for the day is just getting back into what are the features of the Rust standard library. And then I'll just have to play with some of the key bindings, right? I had to look up how to refactor this. I'll just have to play with those a little bit. So there you go. That's day one. Again, I'll link my solution. I'd love to see your solutions. So just create a fork or whatever, or of my gist that I'll submit, and we'll see you tomorrow for day two. Day two.